Good morning, students. Up to the last lecture, we have studied about the topic of resolution. Okay. In first lecture, we have studied about the concept of heat. Okay. Then after that, we see the effect of heat. Okay. Due to the effect, what happen in the state of substances. Okay. That part also we see. Also we study the latent heat concept. Okay. Latent heat of melting and latent heat of vaporization, and in the last topic we have studied, that is the what resolution. Now today we have to see next topic, that is the anomalous behavior of water. Okay, anomalous behavior of water. Okay, so anomalous behavior of water means it is somewhat different behavior. Anomalous means what? Somewhat different than regular. Okay, so what is the different nature of water that we have to see in this topic? Okay, so first off, directly goes toward the anomalous behavior. We see first some points. Okay, so generally, if liquids are heated, okay, if we heat any liquid at that time, up to certain extent, up to some time, okay, up to somewhat limit, we will find that expansion in their volume takes place. Okay, we see generally liquids. In case of liquids, we start heating. Okay, as we start heating, at that time, up to certain time, okay, means up to certain heat we are given to that liquid. So up to somewhat stage, up to first somewhat time, we will see that expansion in their volume takes place. Expansion means what? Their volume increases. Okay, so as we heated a liquid up to somewhat extent, then what happen? Expansion in their volumes takes place. Okay, now we think or we apply this to in case of water. Okay, we know at 0 degree Celsius, if we heated ice at that time at 0 degree Celsius, it get converts into the water. Okay, so look at, we take water at 0 degree Celsius and start to heating it. Okay, what? We take water at 0 degree Celsius and start to heating it. Okay, the general rule is, if we heat liquid, okay, so up to somewhat extent, what happen? Their expansion in their volume takes place. Look at what happen about the water when we try to heat it. Okay, from 0 degree to onwards. Okay, look at, so but if heated water in between 0 degree Celsius to 4 degree Celsius, okay, look at, rule tells us generally if liquids are heated, so up to some time they will show increase in their volume, expansion. Okay, but in case of water, if you try to heat it, so initially between 0 degree to 4 degree Celsius, what happen? Contraction in their volume of water takes place. Okay, look at, general rule is, if you heated liquid at that time, initially up to some limit, what happen? Expansion in their volume takes place. But now in case of water, look at here, if we try to heat initially 0 to 4 degree Celsius, if we observe this first 4, 1, 2, 3, 4, okay, so this 5 degree Celsius, 0 degree to 5 degree, 1, 2, 3, that is a 4 degree first. Okay, so in that 4 degree Celsius, 0 to 4 degree Celsius, what happen? Contraction in their volume takes place. Contraction means what? It decrease. Okay, its volume decrease. So if we heat liquids up to somewhat limit. Generally, in case about the liquids, their volume increases. But now, if we apply this rule in case of water, there are, we see, exact different nature or different phenomenon in case of water. Okay, so this different nature of water as compared to the other liquids. Okay, so this different nature of water as compared to other liquid in temperature between 0 degrees Celsius to 4 degrees Celsius is called anomalous behavior of water. Anomalous means what? Somewhat different behavior. Okay, look at, again I will tell you what happened about the liquids. Okay, in case of liquids, generally if you heat liquid, okay, at that time initially up to somewhat extent, okay, up to some limit, okay, if we supply heat, at that time expansion in their volume is takes place. Okay, so this is the general rule or general observing condition about the liquids. Okay, but now if we try to find out this case in case of water, okay, if you try to test this rule in case of water, then one thing we will be find there, that when we try to heat water in between 0 degree to 4 degrees Celsius, okay, we are supplying heat to water from 0 degrees Celsius, so up to 4 degrees Celsius, okay, by the supplying it, their temperature will be increased. So 0, 1, 2, 3, 4 up to 4 degrees Celsius, we will be find that their volume decreases. Okay, and that is a different from the nature of all liquids. Okay, in generally liquids expansion takes place, but in case of water, if you heat it from 0 degrees Celsius to 4 degrees Celsius, then contraction means its volume minimized here. Okay, we can say that decrease in volume of liquid takes place there. Okay, so this is different nature. Okay, somewhat different nature of water as compared to the other liquids is simply called as the anomalous behavior of water. Okay, so in the definition of anomalous behavior of water, you have to write, okay, if we are heated water in between 0 degree to 4 degrees Celsius, okay, instead of expansion, compression or contraction in their volume is takes place. Okay, so this is the different nature of water as compared to the other liquids. Is called as what? Anomalous behavior of water. Okay, now here one graph of anomalous behavior of water is given. Okay, that graph is also there in our book. Okay, so we have to draw here graph volume in centimeter versus temperature in degrees Celsius. Okay, 1 kilogram of water they take and they observe when we start heating of this water from this temperature 0 degrees Celsius, okay, over up to somewhat limit, what happened about the volume of water. Look at in x-axis temperature in degrees Celsius is takes place. Okay, 0, 1, 2, 3, 4 is the temperature in degrees Celsius. Now in this y-axis, what? The volume of water in centimeter square takes place. Look at a 0 degrees Celsius, here temperature is how much? 0. So at a 0 degrees Celsius, our volume of 1 kilogram water is 1000 centimeter square. Okay, now what do they here? Increase temperature of water. Look at, suppose at 1 degree Celsius, this is the volume of water. Okay, this is the 2 degrees Celsius, this will be the volume of water. This is the 3 degrees Celsius. This will be the volume of water. Okay, and now this is the 4 degrees Celsius. Okay, at 4 degrees Celsius, this is volume of water. Look at 5 degrees Celsius, this is the volume of water. 6 degrees Celsius, this is the volume of water. 7 degrees Celsius, look at, this is the volume of water. This is the 8 degrees Celsius, this will be the volume of water according to x and y axis. Okay, so look at actually what happened in this graph. Okay, so I just tell you how scale variation takes place over here by comparing x and y axis. Okay, look at initially. Okay, when water is at 0 degrees Celsius, okay, at a 0 degree, volume of water is this. Look at, okay, in between 1000.10 to 1000.15, okay, centimeter square in between the volume of water. Okay, now this is 1 degree Celsius. Okay, as we supply heat to water, due to that its temperature increases. Now at 1 degree Celsius, look at, this is the volume of water, so it decreases. Look at 0 degree Celsius, this is the volume of water. Now at 1 degree Celsius, this is the volume of water. It is less than 1000.10. Okay, now look at, further we supply heat, it will increase the temperature of water. So look at here, at 2 degrees Celsius, volume of water will be still decreasing. Okay, it is less than again this value. Okay, so now further we supply heat at a 3 degrees Celsius, again look at here, volume of water decreases. Okay, so continuously if we supply heat to the water from 0 degrees Celsius, due to that what happens, temperature increases. At 1 degree Celsius we will see, and if you look at volume at the same time, then we will see that decrease in their volume takes place. Look at 4 degrees Celsius. Okay, at a 4 degrees Celsius, its volume become minimum. Okay, become minimum. Look at a 4 degrees Celsius, it become 1000 centimeter square. Okay, it is the minimum volume of water at 4 degrees Celsius. Okay, so look at, from 0 degrees Celsius, it is maximum at 0 degrees Celsius. Okay, and as we increase the temperature of water, then we will see that regularly decrease in the volume of water takes place from 0 degrees Celsius to the 4 degrees Celsius. Now look at what happened after 4 degrees Celsius. Okay, still we supplying heat, so its temperature will be increased. So at a 5 degrees Celsius, its volume start to increase. Look at 4 degrees Celsius, minimum, lowest, and after 4 degrees Celsius, look at 5 degree, it will be somewhat here. Again 6 degree, it will be somewhat here. 7 degree, it will be somewhat here, and 8 degrees Celsius, again somewhat here. Okay, so up to 0 to 4 degree, what happens? Its volume decreases. But in case of liquids, if you draw this graph, in case of liquids, so we will see from 0 degree, increase in the volume of that liquid takes place in other liquids. But in case of water, what happens? First 0 to 4 degrees Celsius, contraction in the volume of liquid takes place instead of expanding. But after 4 degree, it will increase. Okay, it is according to rule. Okay, according to rule, what says? Rule says that as we heat liquid, so expansion in their volume takes place. But in case of water, this first 0 to 4 degrees Celsius, it decreases. Okay, and this different nature of water as compared to the other liquids is called as anomalous behavior of water. Okay, if you see the other liquid, then we will see directly increase in their volume. So such a graph will be there in case of other liquids. Okay, but in case of water, what happen? Up to 4 degree, its volume decreases. At 4 degree, it is minimum, and after 4 degree, what happen? It start to increase. Its volume start to increase. So this is a different nature of water as compared to the other liquids. In between temperature 0 degree Celsius to 4 degree Celsius, this called as the anomalous behavior of water. What? Anomalous behavior of water. Look at these things we have to know first. Generally, if liquids are heated, okay, due to heat, what happen? Expansion in their volume is takes place. Okay, due to the supply of heat, what happen? Volume of liquid get expand. But now, if we heat water, okay, in case of water, if we heat water between 0 degree Celsius to 4 degree Celsius, at that time we will see that this case is not happen there. Okay, water is also liquid, so this is a rule for liquid generally. But in case of water, we will see that first 4 degree Celsius decrease in volume takes place over here. At 4 degree Celsius, this volume is the lowest. Okay, and now after 4 degree, what happen? Volume increases. This rule is obeyed. Okay, this rule is obeyed after 4 degree Celsius, 5, 6, 7. Okay, at that time volume will get increased. But if we talk about this first 4 degree Celsius temperature, then we will see that contraction in the volume of water is takes place, and this is somewhat different as compared to this rule. Okay, so that is the somewhat different nature of water in between 0 degree Celsius to 4 degree Celsius, in that instead of expanding, contraction in the volume of water is takes place, and that different nature of water in between 0 degree Celsius to 4 degree Celsius is called anomalous behavior of water. Okay, so that much thing you have to write. So important note down things are this: generally liquids are heated, then expansion in their volume takes place. But in case of water, 0 degree to 4 degree Celsius, what happen? Instead of expansion, contraction is takes place. Okay, so due to that, what happen? This is a somewhat different as compared to the liquids. So this different nature of liquids as compared to the this different nature of water as compared to the other liquids, that's called as a anomalous behavior of water. Okay, I think you should be got it. If you have any problem, then please ask me remaining topics. So that is the one experiment we have to see, that is the Hope apparatus. Okay, to study anomalous behavior of water. Okay, that we will be seeing in the next lecture. If you have any problem about this topic, previous topics, then please ask me. Okay, so next topic we will see in next lecture. Thank you.